We've looked at a little bit at the Pythagorean theorem, and it is a squared plus b squared equals c squared. So the short sides of a right triangle, this only works for right triangle, if you square them, it equals to the hypotenuse squared. So if squaring is area, so this is an a by a rectangle or square, and this is 6 by 6, so this is 36 squares. This one's 8 by 8, so this is 64 squares, and that is equal to 100 squares. The converse of the Pythagorean theorem is if a squared plus b squared equals c squared, then it's a right triangle. Pythagorean triples are whole numbers such that a squared plus b squared equals c squared. So common Pythagorean triples are 6, 8, 10, 5, 12, 13, and any multiple of them. So if you know that 6, 8, 10 works, then 3, 4, 5 works. If you know that 5, 12, 13 works, then 10, 24, and 26 works. And I can multiply this by 2, so it could be 20, 48, and 52. That works too. Well, so how can you tell if a triangle is right? We know it's right if a squared plus b squared equals c squared. So for example, 3 squared plus 4 squared is 5 squared. So therefore, the sides 3, 4, 5 make a right triangle. How can you tell if a triangle is acute? So if you think about an acute triangle, let this be A, let this be B, let this be C. In order for this to make a right triangle, you'd almost have to stretch this out right there, that side. So I'm going to do, the rule or the law is a squared plus b squared is going to be greater than c squared. C is short. And if it's obtuse, it would be a squared plus b squared has to be less than c squared. C squared is longer. So if 3, 4, 5 is my Pythagorean triple, an example of an acute triangle would be 3, 4, something that's less than 5, but more than 4, so 4.5. An example of an obtuse triangle would be 3, 4, and then a side that's greater than 5, but just like in a triangle, it still has to be less than 7, so 6 would be an obtuse triangle. So, example 1, is this triangle a right triangle? So you have to check take the two short ones, so 6 squared plus 9 squared. See what that is, so 36 plus 81, and then 13 squared is 169, or 169. So the relationship between the two is this 169 is greater than 36 plus 81. So that means that this is an obtuse triangle, not right triangle. Example 2, tell me if these numbers are acute, obtuse, or right. So do 15 squared, take the two shorter side, plus 20 squared, which is 400, and is that equal to 25 squared, which is 625? Well, these are equal. The a squared plus b squared is equal to c squared. So then that means it's right. In this one, I'm going to take the two shorter sides, 100, because that's 10 squared, plus 225, and I'm going to see the relationship with 400. Well, 400 is greater than this side, so this is an obtuse triangle. Example 3, a right triangle has legs, so this means legs are A and B. Find the length of the hypotenuse, so C. So 16 squared plus 30 squared equals c squared. So I'm going to go to 16 squared is 264, so 264 plus 900, and that's equal to c squared. This is 1164 equals c squared. So first I'm going to do the square root of 1164 and see what I get. So I do 1164 and I square root it. Ooh, I think I messed up. 216 times 16. Oops, 256, sorry. So this is 1156. So do the square root of 1156 first and see if that is a whole number. Well, this happens to be a whole number. This has to be 34. But if it's not a whole number, you're going to write it exact, and you're going to want to factor it and split it off. Example 5. A baseball diamond is a square with 90-foot sides. Home plate and second base, this is home plate, this is second base, are at opposite vertices. How far is it from home plate to second base? So you're basically trying to find, if this is a baseball diamond right here, you're trying to find this length, which is the hypotenuse of a right triangle. So you do 90 squared plus 90 squared equals c squared. 90 squared, 8100 plus 8100 equals c squared. So I do 8100 plus 8100. $1620 equals c squared, or 16,200. So I'm going to take the square root of this. You know, because we're talking about a real life problem, I did not, right here, up here, I would have said, you know, we need to break this down and factor it, but because we're talking about a real life problem, nobody's going to write, you know, it's a square root of 5 root 70 is the length. You're going to want to actual round it to the nearest foot. So I'm going to do the square root of 1620, which is about 127 feet. And then solve for x. So I have, this is my c, because this is across from the right angle. This is my a, this is my b. So I'm going to do x squared plus 5 root 7 squared. Notice how I put parentheses around it, so I make sure I square the 5 and the root 7, equals 5 root 13 squared. So x squared plus 25 times 7 equals 5 times 13. 25. So x squared plus 25 times 7 equals 25 times 13. So I subtract 175 from each side. So x squared equals 150. And now I'm going to break down the square root of 150. In this case, normally with the quadratic I would do plus or minus, but since we're talking about a distance, I'm not going to do plus or minus. So it's x equals, the square root of 150 is 25 times 6. So it's 5 root 6 is your answer.